Welcome everyone to the AI Research Roundup. I'm your host Alex, where we dive into the latest happenings in AI research. Today we're looking at a paper called VLFM Vision Language Frontier Maps for Zero-Shot Semantic Navigation, published December 6, 2023. So this paper tackles how robots can navigate new places to find specific objects, kind of like how humans use semantic knowledge to explore. They introduce VLFM, which uses vision and language models, essentially to make educated guesses about where a target object might be, even without any prior map or experience in that specific environment. It's zero-shot, meaning no task-specific training is needed. Okay, and for anyone interested in trying this out themselves, the authors have actually made their code publicly available. What we're seeing here is the GitHub repository for VLFM. It seems pretty comprehensive. You get the code itself, instructions for setting everything up, scripts to download the necessary datasets and model weights, and even how to run the evaluations or deploy it on a robot like they did. So it really provides the tools needed to replicate their results or build upon their work. Alright, so to give you a better idea of how this VLFM approach works in practice, let's look at this first figure. It shows a top-down view of an environment. You can see two paths. The green one is the VLFM agent we've been talking about, and the red one is a simpler, greedy frontier-based agent. Both are trying to find the target object, which is the bed in this case, starting from the blue square. Notice how the VLFM agent's path is guided by that colored overlay, the value map, which represents where the model thinks the bed is likely to be. It takes a much more direct route, while the red agent explores more widely before finding it. This really highlights how VLFM uses semantic understanding to be more efficient. Okay, building on that idea of using semantic information, this next figure breaks down the VLFM process a bit more. So it starts with an initialization phase, where the robot basically looks around. Then it enters the main loop, called semantic frontier exploration. Here, it uses observations like RGB images, odometry, and depth data to build both that value map we saw before, and also a frontier map, which identifies the edges of explored space. It combines these to pick the best frontier, the most promising direction, and navigates towards it. If the target's found, it switches to goal navigation. If not, it just keeps exploring. Okay, so diving deeper into how that value map gets created. This figure really zooms in on that specific part of the process. We mentioned before that the system uses vision and language. Well, here you see it in action. At each step, like at time t=0, it takes the current RGB image and a text prompt, for instance, asking about the target object like bed, and feeds them into the BLIP2 model. This gives a similarity score, shown here as 0.10 initially. This score is then projected onto that top-down map, using the depth data to shape it like the camera's view. Then, as the robot moves, like at time t=1, it does this again, gets a new score, maybe 0.13, and updates the map, essentially layering the information over time to build that understanding of where the object might be. Okay, so now we see how that value map creation translates into actual performance. This table shows the results on standard navigation benchmarks, Gibson HM3D and MP3D. It compares VLFM, our method, against other approaches. Notice the semantic nav training column. VLFM uses none, meaning it's zero-shot. The key metrics are SPL, which measures path efficiency, and SR for success rate. Higher is better for both. You can clearly see VLFM outperforms the other zero-shot methods like SEMutil and ESC on all datasets. For instance, achieving much higher SPL and SR on Gibson and HM3D. This really demonstrates that leveraging the vision language model for semantic guidance works very well in practice. Alright, so those results really highlight the power of VLFM. The big takeaway here is how effectively it uses vision language models to directly guide navigation in a zero-shot way, building that semantic value map on the fly. It shows we can get impressive performance without needing specific training. This really pushes towards more adaptable, general-purpose robots that understand language instructions better in unfamiliar spaces. Okay, that's our show for this week. Thanks for listening to the AI Research Roundup. I'm your host, Alex.